we have a treat today, because you're going to hear some things that you probably knew about, both academically and politically, but it really brings into focus what kind of the dark ages that we've come out of when you're being addressed by someone who calls himself a professor in exile. Dr. Matthew Wielicky is a geologist, is a climate scientist. He's been through the rigors and the ropes. He's actually extremely interesting to listen to. I will let him tell you more about his education when we sit down afterwards and we talk about where he's been and where he is now recently. But beyond the headlines, Understanding Climate Change is a talk that I wanted to bring here for quite some time. And then I heard him do a video on Prager, and I immediately called him and invited to come in. Would you please welcome Professor Matthew Wielicky.
Thank you, Alan. Thank you, everybody, for joining. This is my first time in Aspen. Alan mentioned to me that people visit to ski, but they move here for the summers. I can see why. It's absolutely beautiful. Thank you to the Jewish Community Center and to Aspen Counterpoint. So I'm going to tell you a little bit of story. I'm going to try to convince you that what we see in the headlines and in the media, and even something that is parented by a lot of the top climate scientists, isn't necessarily supported by the observable data. And as a geochemist, that's really the most important thing to me. I need to see the data. And so before I get into that, let me just introduce myself. As Alan mentioned, my name is Dr. Matthew Wielicky. I originally had a degree in biochemistry and cellular biology from UC San Diego. I wanted to go on and be a medical doctor, or as a lot of my buddies in high school say, a real doctor. I see some of them, D's out there nodding. Yeah, they're kind of right. I ended up with a PhD in isotope geochemistry from UCLA. And I've written about a whole host of different things. How kidney stones form, how the Himalaya uplift has affected the climate of the Tibetan Plateau, how continents form. But right when I started my tenure track position at the University of Alabama, I became a father. And I started to look at science a little bit differently. I started to look at what were the effects on my kids of the story that my field, earth science, was telling people. This doom and gloom, this absolute misery that seemed like it was in our future, the planet on fire. It was in my kids' 4- and 5-year-old reading books when they were learning how to read. And I was shocked. I thought, well, I got to go look at this a little bit closer. So I started to look at the observable data, and what I found was really interesting. I found that it wasn't supported. The narrative that we get by the media wasn't supported by the observable data. I've been very fortunate in my career. I've gotten to travel to a lot of great places. You can see in the lower picture there, that's some of the oldest bits of material on Earth. We call that the Discovery Site in Western Australia. My PhD was actually on trying to understand the environment on early Earth during the origin of life. I was really interested in how life originated and whether we started from scratch or whether there were precursory biochemical molecules that were being delivered by meteorites. You may have heard that meteorites have a lot of essential amino acids on them. So we were really interested in kind of this evolution of life. I really wasn't involved in climate too much. I worked as a geochronologist on a lot of climate papers. I was reviewing a lot of climate proposals, but I kind of stayed out of the field because it was already politicized by the time I was getting into my degree. I've gotten to go to the Tibetan Plateau. You can see there at the bottom left, that was my last lecture at UA before I left. Al and I will talk about that a little bit more later. But essentially what I'm going to do is I'm going to use 3 recent examples to highlight to you how there is this disconnect between what we hear by the mainstream media, by climate scientists / activists. I don't know how many of these people I would consider scientists anymore. I think they're a little bit more on the activist side. By intergovernmental organizations, by politicians. There's this symbiosis that has occurred that is pushing a narrative. But if you just dig down a little bit, you'll see that that narrative is not actually supported by the observational data. And we're going to look at 3 recent examples, right? We'll talk about flooding in North Carolina after Hurricane Helene. We'll talk about that was late September of last year. The Palisades fire early January of this year. And just a few days ago, the flooding, tragic flooding that happened in Texas. And I think that these examples are going to show you how we have this media sensibilization that's going on, and it's not supported by the data. So let's start with Asheville, North Carolina. This was a tragedy. This was the remnants of Hurricane Helene, late September of last year. Enormous amount of rainfall over a short period of time along the French Broad River. So this is the French Broad River. We're looking down at Asheville. You can see a picture on your right-hand side before the river flooding, and on the left, a shot with the flooding that occurred. So this was tragic flooding in a beautiful town. I got to go speak there once before. The next day, just like clockwork, the headlines looked like this. Everything was blamed on supercharged hurricanes. And these aren't little media organizations. This is NPR. Climate change made Helene more dangerous. The Union of Concerned Scientists. I have a lot of respect for them. Hurricane Helene and Milton, further proof we're not ready for fossil fuel-caused climate change. The Associated Press. Climate change boosted Helene's deadly rain and wind, and scientists say same is likely for Milton. And then the World of Weather Attribution. Climate change, key driver of catastrophic impacts of Hurricane Helene. The narrative was there. This was due to increased CO2 and warming, which was supercharging hurricanes. That seems simple enough to go investigate. So that's what I did. So I went and took a look at the data. So in the upper plot, what you see is temperature anomalies for a little narrow strip of the Earth from the equator to 30 degrees north latitude. That essentially incorporates the northern Atlantic, where we get our Atlantic hurricane systems. And notice that the time frames are matching up. And so in the lower portion, I have an EPA plot of the number of hurricanes that have hit the United States. So you can see there's the total hurricanes adjusted, the total hurricanes unadjusted, and the hurricanes reaching the United States in the dark red at the lower portion. The reason that it's adjusted is because prior to really good aircraft and going out and trying to categorize hurricanes, sailors really tried to avoid hurricanes as much as possible. So notice that the adjusted number for total hurricanes goes up a little bit in the past as you go back in time. That's just because we just assume we missed some. We just avoided any time there was a hurricane. And this is really kind of wishy-washy data. Number of hurricanes goes back to 1880. This is literally looking through ship logs, trying to see the smeared rum and see if they wrote down the wind speed and if they thought it was a hurricane. But I'm an isotope geochemist. I want a little bit more than this. This is very qualitative to me. I like quantitative data. So I plotted this. So this is now satellite data. So let's focus on the lower plot first. So now we're again talking about the global sea surface temperature. So we're not going back to the 1800s anymore. We're only going back to 1990 now, because this is all satellite data. And instead of just counting hurricanes, because we have satellites, we came up with a new metric. We have now a quantitative way that we can measure the strength of hurricanes. We call that the accumulated cyclone energy. So you can see that here on the upper plot. That's the y-axis in the upper plot. Now notice the sea surface temperature has been going up. It's gone up, about 0.4 degrees Kelvin or so, 0.4 degrees Celsius. Kelvin and Celsius are equivalent. But notice in terms of the accumulated cyclone energy, we see a decrease in all of global hurricane energy. At the same time, we're seeing an increase in the temperature. This idea that warming is driving supercharged hurricanes is clearly not supported by 22 years of satellite data where we're actually doing the real measurements as opposed to relying on things like sea logs and things like that. And these floods have happened before. This is an image from 1916 of the French Broad River. Again, this is Asheville, North Carolina. This flood was not as big as the flood last year, but we have this weather amnesia. This is not that long ago. 1916 is not that long ago. And if you add in the paleo flood record, so I used to teach at the University of Alabama. Thankfully, I was good friends with the Alabama State climatologist. His name is Dr. John Christie. He's at the University of Alabama, Huntsville. And I had wrote something on my Substack to bring attention to the fact that Asheville had recent floods. And he drew my attention to a master's thesis from UA, where I was, that had just recently been published. This was funded by the Tennessee Valley Authority. They're primarily in charge of the hydrology and developing all the hydrological infrastructure in the Tennessee Valley, but also in North Carolina near Asheville. And what you can see here is now we have paleo flood data, meaning ancient flood data. So what they did is they went and looked along the stream and they dug down and they looked at the layers that were deposited, because when a flood breaks over the stream, it dumps a lot of the sediment that it's carrying. And so you can go and look at the floodplain and you can kind of figure out when ancient floods had happened. What they found was that the flood that happened at the French Broad River, which I have here in the lower portion, I know it's a little hard to see, so I'm just going to tell you, it crested at 25 feet. 24.67, I think, was the official number from NOAA. Let's just call it 25 feet to make it even. So here on this upper plot, you can see the paleo flood data. That goes all the way back to the late 18th century, early 18th century, 1720. And notice that this on the y-axis is the crest in feet. In 1790s, in the late 18th century, we had 2 flooding events that matched the flood that we had last year. And this was before there was any real development, right? You have to remember now when we build cities and we build infrastructure along rivers, we funnel a lot of the surface waters into the streams very rapidly because we want to protect the infrastructure. This, in the late 18th century, was long before any of that happened. This is a natural flood with almost no river infrastructure on the water. So this is not an unprecedented event. Something that happens on the century time scale is definitely not something we shouldn't be planning for. This is something we should be planning for. Instead, we're blaming a trace gas in the atmosphere. Let's go on to the Pacific Palisades. This one's a little bit near and dear to my heart. I went to UCLA. I lived very close to this area. I took my wife to some of our first dates along the PCH that burned. So this was early January of this year. A tragic fire in the Pacific Palisades, also in the Altadena area in north of Pasadena. Loss of life was relatively low because we had good warning systems. Most of these folks escaped. But the amount of damage to infrastructure and to housing was pretty remarkable. And like clockwork, the next day, so I'm going to ask the question, were these fires fueled by climate change? This is a picture from the TCW rooftop. So my son was born at UCLA, which is somewhere off in the distance over there. This is looking towards Miracle Mile, towards west, towards the coast. That's Brentwood right below the flames that didn't actually burn, was relatively saved. But that's Pacific Palisades burning all the way up to the Getty Center, essentially. But the question's always the same. Does this have to do with climate change? And like clockwork, if you ask a climate scientist, this is what they'd say. So this is Dr. Michael Mann. I think he's probably the most famous of the climate scientists that exists. He's the primary provider of the hockey stick graph that you may have heard. And CNN interviewed him. The video was a little choppy, so they posted what he said. So I'll just take the post. At Michael E. Mann, that's his Twitter handle, says it best, or X handle now, says it best. LA wildfires are a direct result of human-caused climate change. Rising temperatures and dwindling rainfall leave the land bone dry, fueling the perfect conditions for these devastating fires. Well, we can ask this question. These are things that we can test. Let's take a look. Was SoCal unusually dry? Oh, this should say hot. Sorry about that, that's a typo. So this is a temperature plot. This is downtown Los Angeles from 1875 all the way to 2024. You can clearly see that Los Angeles is warmed. In 1880s, the population was something like 1/100th of what it is today. So the development of the town and the city has definitely warmed temperatures. But this is a mean annual temperature. And notice the mean annual temperature is back to the temperatures in the 60s and the 70s. It's not particularly hot. The decade prior was significantly warmer, and before that, in the late 90s, was even warmer. But really, that's not what we want. We're not really interested in the mean temperature, because what Michael Mann is saying that the extreme heat, the high temperatures in the day, that's what's drying all this fuel, and that's what's causing the ideal conditions for these types of fires. So we can look at that. Let's take a look at the mean maximum temperature now for downtown Los Angeles. Remember, the fire was in January, so this is between December and February. I decided to take December and February just to get a longer average. The fire happened January 7th. So notice the temperatures have slightly increased. The mean maximum temperature in downtown Los Angeles has slightly increased since the late 1900s. I don't see any sort of rapid uptick or anything that seems unusual or unprecedented in this. I'm not going to argue that the temperatures in Los Angeles between December and February aren't slightly warming. They definitely are. But I don't see this unprecedented heat that I hear that is making for these ideal conditions. Both of these should have said heat. Now let's talk about dry. Let's talk about precipitation. This is a plot of the annual rainfall from downtown Los Angeles from 1887 to 2024. The last decade or so has been relatively dry in Los Angeles. That is true. But notice the last two little bars on this plot. That's the years 2022 to 2024. That's the second wettest back-to-back years in downtown LA history. If anything, Los Angeles was particularly wet at this time rather than particularly dry at this time. Is California really dry in general? Let's take a historical perspective. We reduce climate change into human timescales, but that's not how the Earth operates. The Earth is 4.5 billion years old. There's many timescale patterns that are much beyond our human timescale. So taking a historic perspective is really important. So what I'm showing you here is a plot of the drought. So the more red the colors, the more we are in a drought, drier we are, the more blue, the wetter we are. And this is going back all the way to prehistoric times. This was published a few years ago in Earth Science Reviews. What you can see is that overall, in terms of California's drought history, we're in a relatively wet period. It appears that we had multi-century droughts in the medieval periods, in the medieval ages. That's remarkable. That would be devastating to California today. But clearly that was at a time where CO2 was at pre-industrial levels, so you can't blame CO2. This is just natural variability. There's no developments, there's no SUVs, there's no fossil fuel plants. This is just the natural variability of the drought, the seasonality of droughts in California. And this is really predominantly driven by things like the El Niños and La Niñas. The currents in the Pacific are really what are driving how much heat and moisture that the California state in the western coast gets. So it doesn't seem abnormally dry either. So what about the winds? FEMA administrator came out and said, look, we were ready for this. This was, we have all guns were ready to go. We had everybody on the line, but this was just something we had never predicted before. There was 100-mile-an-hour winds, and there were 100-mile-an-hour winds in Altadena and in Pacific Palisades. That's pretty remarkable. But when I was at UCLA, I lived on my sailboat. And on my sailboat, I remember that the winter of 2011 to 2012, we had to batten down the hatches every other day, it felt like. We were loosening lines and retying lines, jumping in dinghies to catch boats that had blown off their slips. And so I just did one quick Google search, and I noticed this from November 30th, 2011. Now, technically, she was correct that 100-mile-an-hour winds were unprecedented. They hadn't happened. I would tend to argue that if 14 years prior to this event, you had 97-mile-an-hour winds, that maybe you should be prepared for 100-mile-an-hour winds, as those are relatively similar. The preparedness for 97-mile-an-hour wind and 100-mile-an-hour wind isn't that different when you're talking about FEMA or an agency that's responding to disasters. She also went along to tie this to climate change, which I found very interesting. Notice Michael Mann didn't make that mistake. He didn't say that the winds were associated with climate change. He said that the heat and the dryness was associated with climate change. That's probably because he had read this paper. You guys may not be able to read what's highlighted, so I'll read it for you. All GCMs, that's global climate change models, project decreases in Santa Ana wind activity starting in the early 21st century, which are commensurate with decreases in the southwestward pressure gradient force that drives these winds. So Michael Mann had probably read this paper, so he didn't make this mistake. But the FEMA administrator, who should know this science, just went along with the narrative. It's this runaway train where you just say, look, this was unprecedented, climate change made it worse, and future climate change is going to make it worse, regardless of what the data says or the observational data. But it's clear that the real climate scientists aren't predicting any increases in wind activity. All right, let me give you another little bit of prehistoric framing here. So this is what if you plotted the acres burned in California since prehistoric times, you can see that since the 50s into the 2000s, we have seen an increase. There's no doubt about that. There's more acres burning every decade as we go along. I would argue that has much more to do with developments moving out into fire-prone areas than anything else, and zoning problems. But we have to understand what happened naturally prior to us actually, developing California. Notice the prehistoric numbers there. The idea that our natural, the acres that burn in California today is somehow unprecedented or unnatural is completely blown away by this chart. We're still talking about something like 1/10 of the acres burned compared to prehistoric times. We know that's true because we know people used carbon isotopes to look at smoke from a fire. And what they saw was that in California, the fuel that was feeding the fire was multi-decade old. The important part about showing you that previous slide was that the recurrence interval for these fires before we got involved was very short. We had low-intensity fires coming through often. We've gotten so good at suppressing fires now that we leave multi-decadal fuel sitting there waiting, and it's what ignites and turns into these giant fires. It has nothing to do with climate change. This is forest management. This is water management. This is the reservoir that was just above the Pacific Palisades. That's it right there. That's a picture of it the day after the fires. It was completely dry. This is a management problem. This is not a climate problem. I predict that the Palisades fire will be the first $500 billion disaster that was completely predictable and completely preventable. The estimates right now are in the $100 to $150 billion range. Once you get through all the environmental regulations to rebuild these homes, especially homes on the coast that have old septic systems, I think you're going to see this number, just like we did with the high-speed rail in California. That original estimate's going to go up. I really do think this will be the first $500 billion disaster that we could have completely predicted and completely prevented. All right, I'll just finish talking about the Texas floods. That picture didn't come up, but it should come up now. Oh, And it should come up now. Okay, so this was just a couple days ago. Texas floods, this was a stalled system that hit Texas in the central Texas area. This was terrible. In the middle of the night, a lot of loss of life. I think the latest estimate is above 80. I think we're going to see it break 100. I don't mean to talk about loss of life in any sort of way to demean it or anything. What I really want to do is focus on the science of why these things happen so that we can stop the loss of life in the future. I think blaming climate change is only going to lead us down a road where we're going to see these same types of disasters. But let's dispel a few rumors. So right away, the day after these events, Jay Inslee, former governor of the People's Republic of Washington State, made this statement. It is hard to make the Texas flood tragedy worse, except to know that on the same day Trump signed a bill cratering solar and wind energy that is vital in the battle against the climate change, making these torrential rains more frequent. And the owner of Midas Touch, a big media organization, jumped right on board, right? And went on to mention that this has to do with staffing issues and cuts at the National Weather Service and things like that. The warnings didn't go out in time. We don't have all this data yet, so I'm not going to give you a lot of the data, but I'll just dispel these couple rumors real quick. The first one is this related to rising CO2. Well, thankfully, the EPA already did this. In 2015, it's a little bit old, I'll give you an update here, but this was the most recent kind of big survey that they did. The EPA looked at regional trends of magnitude of river flooding in the United States from 1965 to 2015, a time period of warming, a time period of a lot of emissions of CO2. And when you look at the plot in general, I think what you'll notice is there are some arrows pointing up. That would mean an increase. Some arrows pointing down. That would mean a decrease. But it seems relatively random. But let's draw our attention to where these floods happen. They've happened in central Texas. So that's right here. So notice in East Texas, near the Texas-Louisiana border, we do have some increases in flooding in those regions. But where the flooding happened in central Texas, which is near San Antonio and Austin region, which is right here, notice that every single arrow is pointing down. What does that mean? That means from 1965 to 2015, the EPA has concluded that there has been a insignificant, because most of these are hollow points, a decrease in the magnitude of river flooding in the area where this flood occurred. Oh, that went too far. So that's old. That was 2015, that's a little bit old, so let me update that. It does not end a pretty plot, but I found this from the state climatologist of Texas at Texas A&M. This was a review they put out just last year, so I highlighted that in the executive summary. I know you can't read it, so you can see it up there. No long-term river flooding trend has been identified in the observations, nor is such a trend projected at this point. And here is the official warning that went out. It went out 3 hours before the flood hit. Unfortunately, this was the middle of the night. The push notifications that went through, it seems like a lot of the flood victims slept through, or they didn't have their location services turned on. But it's clear that the staffing at the office that runs this is the National Weather Service office that's in San Antonio and Austin that runs both of those. They had 5 folks on staff as opposed to the normal 2. So they were already predicting that this could be a heavy event, so they had extra staffing on hand. So this has nothing to do with staff cuts or anything like that. Ultimately, it comes down to this. This is a plot of what I consider climate-related natural disasters, starting from the year 2000 going to today. This plot hasn't been updated for a couple months. That 2025 bar is going to go up. But ultimately, what you see is that there's been no increase in all of these extreme events, whether it's floods or droughts or storms or wildfires. They undulate. There's years where we have pretty bad ones. There's years where we don't have many. But there's clearly no trend. There's none of this narrative that what we're doing, the fact that we have lights on, the fact that we are using energy and living our lives the way we do, that is somehow having an effect on the intensity or frequency of extreme weather. That is a narrative that is born out of this symbiosis between the media and academics and intergovernmental institutions and green tech funds. But it's not supported if you look at the actual numbers. And this is all that matters. Everything else is a black box of inputs and outputs. But until you see it in the observational data, it's just hard for me to accept it. All right, well, thank you. That's all I have. But what I do want to mention is if you're here and you sign up for Substack, you can email me and I'll give you a month for free. You can check it out. There's a free subscription where you just get to read a lot of stuff anyway. And then I keep some of the more detailed stuff behind a paywall, which is relatively cheap. But you can check that out. Thank you for your attention.
Before we take questions, we're going to have an interview. Soon it'll be up. Hello.
You push the button?
It's green.
Okay, go ahead.
Hello. Hello again. So tell me, how you doing? Oh, there we go. Now we're working. There's some very important points that I want to review or add to this. First of all, I really appreciate the discussion. As a physician, I have been dealing, and my profession has been dealing, with similar problems. And that has to do with what we're being told about COVID, what we were being told about the COVID injections, the vaccines, what we're being told about how COVID originated. And especially when we looked at the pronouncement from the federal government, from the NIH, that you had to stand 6 feet away from other people. All of this was brought down to us by the federal people and the medical people. And now we find out it was based on nothing. It was based on no data whatsoever. And I'm embarrassed by the fact that the medical profession, and I'm sure Mark would probably agree with me, has gotten to a point where so much has become political or DEI involved as opposed to data. And that's one of the reasons I asked Professor Wielicky to come and talk with us about data. We got politics as opposed to data. And this has made decisions in professions that were decisions that should not have been made. So I guess I want to start by asking something that we discussed before, and that is the importance of words. We heard yesterday about the importance of words such as genocide, importance of words such as occupation, and things like that which are simply political and not true when you look at the actual data. And when we talked about this earlier today, Professor Wielicky brought something up that's near and dear to all of us. Could you tell us a bit about the use of the term climate denial?
Yeah, absolutely. So,
and it's good because he's sitting, so he's not going to move back.
I know. I'm sorry. I'm a pacer. I apologize. That was definitely my students would always be like, we're listening to you, but half the time we're just watching you run around the room. The term climate denial is it's such a despicable term. I mean, it's ironic that we're in this building giving this talk because it stems from what you guys probably all know is you're trying to hook someone that's questioning science to someone that denies the Holocaust. And that's where it comes from, right? It comes from Holocaust denial. That's the term. And I just find it very ironic. I was born in Wrocław, Poland, which is about 2.5 hours from down the A4 to the gates of Auschwitz. My family suffered dramatically in the Holocaust. We're definitely not Holocaust deniers. But this is this idea where just to question science is enough to turn you into a heretic. And all I'm doing is asking whether the narrative is supported by the data. I don't deny anything. I don't even know how one denies climate. Is that like denying baseball? It exists. Climate exists. It's existed forever. The climate's always changed. I would be much more in fear if the climate stopped changing than if it continued to change. I think stasis is a dead planet. But I just find it despicable to try to attack people's character rather than discuss the science. And that really shows you that you're on the right side of, you get the most flack when you're over the target. And so the narrative is starting to fall apart, and so they're grasping at straws. And one of the ways to do that is to attack the character of the person as opposed to the science.
Speaking of that, would you take us on a short journey as to when you became a teacher in college, ultimately a professor? Why are you a professor in exile?
So my father was an academic. He was a business professor. So it was my dream. I grew up on Cal State Fresno campus, California State University Fresno. My mom was on staff there, so it was always my dream to be on an academic campus. I watched these guys battle in the battlefield of ideas, and then go have a beer afterwards and shake each other's hand. When I got to University of Alabama, I graduated in 2014 from UCLA. I postdoced for 2 years there, and I took a tenure track position at the University of Alabama in 2016. COVID comes around in 2020, and I started to speak a little bit more about climate. I also volunteered to teach classes in person. I said, look, we'll do the 6 feet thing apart. I'll volunteer to teach if the students.
This was during COVID.
This was during COVID, yep. So if they wanted to come to class, I'll be there. And so a lot of times I'll just be there by myself because they told the students they weren't allowed to attend. But I said, I'm going to be there anyway. I'll be there in that lecture room. I videoed it, so I put it out on Zoom. I was just speaking to an empty room. But that really made the administration angry. I signed the Great Barrington Declaration and pushed that we should have schools open. Universities, for sure, these were adults. They should be making adult decisions. But I also had 2 young kids in school. And the last thing was that I highlighted the fact that although the intentions of DEI programs were noble, and I support the efforts, the practice, the outcome in practice at the university was the exact opposite. Students were walking on eggshells. Nobody wanted to interact. There was isolationism everywhere. We had cliques of certain groups by race, cliques by gender. This was not the all-encompassing type of environment. If you disagreed on little parts, it was, you had to be kicked out of the club. So it was this rise of illiberalism that I saw, and I hit all 3. I spoke up about DEI, I didn't agree about the climate crisis, and I had a problem with closing down the schools for COVID. That was pretty much the trifecta for you don't get tenure.
And you're white.
That didn't help.
Thinking of that, once were you fired from your position? Tell us about that and how you came to where you are now and influencing the number of people that you can influence now.
It was the writing was on the wall. It was clear. The Office of Strategic Communications asked me no longer to attend faculty meetings. I was essentially just kind of moved off to the side of the building as the heretic in the building. So the writing was on the wall that I wasn't going to get tenure. So I went to my chair and said, look, let's part ways. nicely. I have no animosity. I really don't. I enjoyed the University of Alabama. I think there are a lot of nice people. I think it's a culture that a lot of young academics just have probably more of a self-preservation instinct than I did. Maybe they're a little smarter than I was. They kept their head down until they had tenure, and then they could speak up after. I kind of missed that boat. But it was an interesting time, but most of the people that I was with were relatively nice, were relatively agreed with me. They just felt they couldn't really say it publicly. The culture was just so toxic at that time that it just don't rock the boat. Why are you rocking the boat so much? Keep your head down. And I just couldn't. I saw us taking these incremental steps, and maybe it's because I come from the People's Republic of Poland. I was very young when we immigrated, but my parents were very sensitive to these things. I would tell my dad all these little boxes we had to check, and he's like, man, this reminds me a lot of why we left, where we left. And it seems like we're doing this all over again. And so the writing was on the wall. If I would have stayed, I wouldn't have gotten tenure, so why go through that? They asked me to stay for one more year to teach, so I stayed for one more year and we parted ways.
Which was very nice of you to do. Needless to say, what's also involved here are grants, federal grants. If you didn't toe the line, if you didn't go with what you were supposed to stay, you didn't get your grant. Your lab couldn't work. Remember, these labs are the most important part of research in this country. And that's just a sorry state. And I want to say one more thing, and then we'll take some questions. I sent out an email with this brochure about a month ago, maybe a month and a half. And it got around, and I did get an email from one gentleman from Down Valley who said, how dare you bring Professor Wielicky to speak? He is a climate denier, and you have a lot of nerve because people shouldn't even hear what he has to say. Now think about that for a moment. That's what the environment was under the past 4 years, and it's been sneaking in this kind of denial, inability to allow people to speak and to have a communicative conversation about anything academic like this. And I said to him, are you saying that we should not have people speak if we disagree with them? And he said, well, certainly, that's what I'm saying. And you think about the kind of environment he's talking about. And this is what Professor Wielicky was talking about, or a professor in exile, not being able to speak what they believe and allow truth to come out in the way that it used to come out in universities, where if you disagreed, you brought up your point and somebody else brought up their point. Now it's shut down. And thank God we're starting to come out of the Middle Ages certainly over the past 4 years plus into some more enlightenment. Any follow-up to finish?
Egg on their face, because once they kicked me out and it became public, I think I reached more people than I ever did in a 350-person lecture hall every semester. If the idea was to silence me by kicking me out of there, then they failed.
How are you reaching so many more people?
So it's really through social media and through Substack. So I write a lot on Substack. That's where I put up all this data that tends to be ignored by climate scientists, by media. And remember, none of this is mine. I don't produce most of this stuff. I just get angry when it's ignored to push a narrative. I think we should look at all the data. You guys should see it all. You should see all the data. You can make your own mind. I've made up my mind. You can kind of tell where I came from to that conclusion. But what I don't like is that we only give you a certain data and then we drive the narrative. You should see it all and you come to your own conclusion.
About 6 years ago here, and we have the videotape of that event online on our site, We had 3 academics from Portland University, including one named James Lindsay. Those people sat up here, the 3 of them, the 3 professors, and talked about a paper that they gave to a prestigious journal that was rejected. It was an honest paper about what their topic was. They then took the same paper and they altered it to conform with this kind of, you can only think one way. And they put that stuff in the paper, same paper, and it was accepted to that journal. These 3 academics helped open the new Austin University that is making headlines about being a university that is open to discussion and open to debate. And it's now getting publicity all over the country. Would that we can have many more of those form. But we're very proud of the fact we brought those people here 6 years ago before all of this became so obvious. Okay. Let's take some questions. We're going to do these 3.
Thank you, Dr. Wielicky, for coming here and speaking your mind. Pardon me? Oh, so the 3 episodes that you mentioned here strike me as being pretty small scale. Like a lot of things can happen in a small area like the Palisades or like Asheville or whatever. What about hurricanes, which are massive scale and which actually I think get a lot more talk about, the rising temperature of water in the Atlantic or Pacific or wherever it is? What's the data show about frequency and the strength of hurricanes, which affect a lot more people than these? Not to disparage anyone dying from any of these things or any damage, but those are much bigger, geological or whatever the right word is, events.
Yeah, sure. Maybe meteorological. So the models are pretty simplistic. They essentially say warm water feeds hurricanes and will increase frequency and intensity. The observational data says the opposite. The waters continue to warm, but the accumulated cyclone energy of global hurricanes has gone down in the satellite era. So this is just the observations don't match the models. Now, that doesn't mean that a hurricane today won't cause significantly more damage, right? But that's just because there's a lot more infrastructure there to get in the way. And this is what NOAA likes to use, these billion-dollar disasters, as evidence that hurricanes are getting stronger. Well, okay, I mean, a hurricane that hit in 1980 in Miami, the same size hurricane would do significantly less damage than it does today. Not because the hurricane's any stronger. So a lot of the data gets distorted, but if we just go back to the physics, the energy of the global hurricane systems, that's all the cyclones in an annual year, and the sea surface temperature, the temperatures are going up, the accumulated cyclone energy of all global hurricanes is going down.
It's easy to agree with hearing that because, well, gee, if the temperature's going higher, it heats the water, and
makes sense.
And it dispels what the actual data might be. So thanks for
It's counterintuitive. I agree with that. It's counterintuitive, but that's what the observations show.
Hi. It's sort of a 2-part question. One leads into the other about the findings of Exxon's own scientists. But when you explain the term climate denier, obviously, when you take those words verbatim, it's meaningless, like a baseball denier. Or physics denier. What you didn't explain is when it's hurled, it usually means that one denies the existence of human-caused climate disruption. You didn't address that and you didn't say that. Is that your position? You accept human-caused climate disruption?
I wouldn't use the word disruption. I do think
instability.
I wouldn't use that word either. I do think we have an effect on the regional temperatures and precipitation patterns. I don't think we have a global effect.
Okay. Right. So then my question is your position that Exxon's own scientists were wrong in their findings that predicted human-caused climate instability by continued use of fossil fuels?
Well, they were wrong because we don't have any instability in the climate system currently. So you have to have the instability for them to be correct. So there's no instability in terms of extreme weather. I showed you that graph. There's no instability in precipitation. There's no instability in hurricane frequency. There's no instability in wildfires. Those are way down. The instability exists in the CO2 levels are higher than they were in the ice cores in Antarctica. Granted, they are. I do think we are having that influence. We are emitting CO2 into the atmosphere. So we are raising the atmospheric CO2, granted. And the greenhouse effect is real. So that CO2, that trace gas, is helping to slow some of the cooling of the Earth, right, by trapping some of the infrared. The question becomes whether we're talking about first order, second order, third order, or fourth order effects. I think the trace gases in the atmosphere are on the order of fourth order effects. The climate system is really driven on the planet by the 70% of the planet that's covered by water. The heat capacity of the oceans is infinitely more than the heat capacity of the atmosphere. The temperature on this planet is governed by the circulation of the oceans. That's it. We are having an effect. I think the urban heat island effect is significantly bigger than the CO2 effect. So urban heat island meaning that what used to be nature is now asphalt, right? And so that's why we see nights tend to be warming the most, is because asphalt will retain that heat and emit it for longer throughout the night than the dirt or the soil or the grass that used to be there. So I don't deny that humans are having an effect on the regional environments that they live in. I don't think they're having a significant global effect, and I don't see any instability in the system. I think the human condition is better today than it has ever been in human civilization. Thanks to cheap and reliable energy.
I don't even know where to begin. Okay, couple.
Here we go. All right.
Polar caps melting.
Only in the north. Antarctica hasn't melted dramatically at all because the melting in the West Antarctic ice sheet is offset by the gain in the East Antarctic ice sheet. So almost mass balance in Antarctica, but yes, warming. The planet's warming.
And so what's causing that?
Oh, well, the same thing that has caused the planet to change temperature since 4.5 billion years. There's never been stasis. We should never expect the temperature to stop changing. That means the planet has died. So the moon, the temperatures don't change on the moon. The sun side's almost about the same and the dark side's always about the same. That means that it's a dead planet. So don't expect change. Remember, what we need to fear is cooling. Cooling is the danger to human civilization. But there's never going to be stasis, so we have to pick. Do you want gentle warming or gentle cooling? I will always pick gentle warming above gentle cooling. And remember, the warming started in 1850, right? Long before CO2 really started to go up. That was the end of the last little ice age. Again, back to ocean circulation patterns changing.
The fact that a lot of us who live in areas, you just pick it, either Texas or Florida or California, we're having trouble getting insurance, right? Why? Because insurers are saying, greater frequency of hurricanes, greater damage, or not even hurricanes, just natural disasters. And I heard you say that wildfires, there's less wildfires now than there have been before. That is a shocking statement to me.
So that's both true locally in California, if you go back to prehistoric times, and remember going back to prehistoric times, but also that's true globally, because we've just really gotten good at fire suppression. We have all these technologies now to suppress fires. So really that's a management problem. But I find it very fascinating that folks wonder why fossil fuel industry would want to maybe keep climate change quiet or something like that, but the insurance agencies wouldn't want to sensationalize it and make it seem worse. Why?
I have to comment on that, because dealing with Medicare, dealing with insurance companies medically, if they find any excuse to deny paying for something, they will do it very quickly. So it's very similar to what you're just saying about the insurance companies, and that's the first thing I thought of when you mentioned that. It's really frustrating.
And State Farm recently pulled out of California, and they made a nice presentation the number one thing they said was the cost of rebuilding. The regulations to rebuild was what's driving them out of the state. Climate change was fourth on the list.
You know, it's really something when you get insurance and then the insurance decides that they can't cover something. You're paying for what they told you they would cover, but of course, if you read the 65 pages of the policy, they've got outlets there throughout. And it truly is similar with medical insurance. Well, I think you've told us a lot about the difference and kind of the reasoning why global warming a couple of years ago became climate change. We all agree that there's climate change. But I sincerely appreciate the information you've given us, Mr. Professor in Exile. Thank you so very much.
Thank you, guys.